we start? I did email y'all last night with the last, what we did on Thursday, which is the end of chapter 5, so if any of y'all need to go back and look at it, you can. I'm recording today, and hopefully today, knock on wood, I'm going to try to do all of 8. If not, I'm going to get the majority of it, because here's my process of elimination. This is my thinking. We only have 2 questions on the exam from chapter 8, okay? And we only have, if we go to the homework, and we go to chapter 8 homework, we have 14 questions from chapter 8. So my theory is, if I can teach as much of chapter 8 today, then you will have the whole Thanksgiving break to do as much of the homework as you can. And then, so today is the 21st. So if I can do, I don't know why I have chapter 5 written there. I wrote it backwards. This is supposed to be chapter 8. So here's my thinking process. If I can do as much of chapter 8 as I can today, then over the break, you can work on chapter 8 homework. And if I have a tad bit to do, then I have a tad bit to do. But then I can spend 2 class periods reviewing for the exam instead of just 1. Okay? Now, I also, in the email that I sent y'all last night, said that I opened up all the homework.
Yeah.
So that if there's anything that y'all forgot to do, or it was back in chapter 1 and you were like, oh my God, this is so hard, I can't do it, and now you're going, oh, that was so easy, what was I thinking? So if there's anything that you want to go back, redo, bring up to 100, but if you're satisfied with it, it's up to you, but I'm giving you a second chance for anything. I made the homework due for y'all. I think it was all homework is due midnight on 11/29, because I want y'all to be done with homework so that when you come in, I don't want you to think about anything else except for the exam review. Now, I did not close the exam review on November 29th. I just closed the homework stuff. So if you go to do homework, everything is open, but see how I didn't put beside the test reviews? I didn't put due dates beside those. So your exam review does not close on the 29th. It is still open. And the homework reviews, remember, the homework reviews do not affect your average. So do not worry about the test reviews. They do not change your average. So don't go back and make sure you do those 75 question ones. Those are not going to change your average. Only the ones that have November 29th beside it. Those are the ones that you need to try to make 100s on. We good? All right, so after today, I will see you a week from today. And then I will see you a week from Thursday, and then your exam is going to be on the 7th. So 2 more lectures after today, and then your final exam. Cool?
Our final exam, what time do we come here? Is it the same time?
During, I don't know. Why are you asking questions? I don't remember. Hold on, I'll tell you. If we go to syllabus page, and we go to final exam schedule, and this is the schedule for the entire school. This is not just for my class. Brittany's already on my actual meeting. Okay, so if I come here, this is posted in my math lab. Most of y'all have day classes, so this is the exam schedule for day classes. So let me just show you. If you have o'clock classes, so if you have 8 o'clock, 11 o'clock, 2 o'clock, your exams are going to be on Mondays and Tuesdays. If you have 30 classes, 9:30, 12:30, 3:30, those exams are going to be on Wednesday and Thursday. So our class is a Tuesday, Thursday, 9:30. So our exam is gonna be on Thursday from 9:30 to 11:30. And the reason they alternate is because our classes are an hour and 15 minutes and the exams are 2 hours. So you can't have your 8 o'clock exam from 8 to 10 and then have a 9:30 exam right after that because they're gonna jam up.
Right.
So Monday, your 8 o'clock exams are from 8 to 10 on Tuesdays, but then your 9:30 exams are from 9:30 to 11:30 on Tuesday, Thursday. So you can kind of tell where all your exams are. Does that make sense? And I'll send you an email of when I'm giving all of my exams. So if you want to come to a different exam, so like if you have 3 exams on that day and you want to come to a different one of my exams, or you want to take my exam early, you can come to any of my exams, I don't care. I had somebody that's going out of town and she wants to take her exam the week before exams because she's not going to be here exam week, and that's fine, just let me know. I'm easy, I don't care. All right, so I'm going to do as much as I can in Chapter 8 today, and there's a reason why, like I said, I saved Chapter 5 and Chapter 8 until the end. Chapter 5 and Chapter 8 are kind of bringing everything together. And I know we kind of finished Chapter 5. We kind of rushed through it a little bit at the end, but this is kind of a Chapter 5 review. And we went over these problems, but I'm going to briefly go over them again because it'll get us ready for Chapter 8. You really don't need to write this down because we went over it last time. 5.2, we did individual data. That is, it is what it is. And group data, we had to redo the standard deviation, which means we had to take the old deviation and divide it by the square root of the size of the group, which made us skinnier. So I gave you some problems. This one says we have a normal distribution with a mean of 170 and a standard deviation of 30. And for this problem, we want to know individual data, which means it is what it is, greater than 167. So 167 is to the left of my mean, and greater means we're shading this way. So we're going to do the normal CDF. Our lower limit, let me scroll up so you can see it. Our lower limit is what we shade on the left. Our upper limit is what we shade on the right. Our mean and our standard deviation. And we type it in exactly like it's written. And then we're going to whoop whoop, and it's going to be 53.98%. Okay, we did several of those last time. Well, then the second part of this question says, well, what if we put 100 people in the group? So we take the same exact thing. I literally cut and pasted this same problem. The only difference is I took the old standard deviation and I divided it by the square root of 100. And I literally typed it into my calculator exactly like it was written. So if I come into my calculator and I do second bars, I go down to normal CDF. My lower limit is where I shaded on the left, which is 167. My upper limit is going to be 999, which is my biggest number to the right. My mean is 170. Because it's group data, I've got to redo the standard deviation, so it's going to be the old standard deviation divided by the square root of how many people are in a group. And I type it in just like that. And then I hit enter, and enter, and enter. That's where I'm getting that 84. So it's really exactly what I did, and I typed that at the end. So those problems are exactly the same, except I redid the standard deviation by dividing by the square root of the size of the group. Cool? All right, here's another one. This one, you have a normal distribution with the mean of 170, the standard deviation of 30, but this time we have 2 data points, 164 and 176, and we want between. The first one says individual data. So my left is my lower limit, 164. My upper limit's 176. My mean is 170, and my standard deviation is 30. I keep my standard deviation because it's individual data. So I go to my calculator, I do the normal CDF, which is second bars, number 2. So it's going to be 164, 176, 170, and 30. I do my whoop whoop, that's where I get my 15.8%. Now, sample of 100 people. Everything else is the same, so watch this. Second enter brings up the problem. I back that thing up, and so now I just have to redo my standard deviation. Old standard deviation divided by the square root of the size of the group. So literally, I took the same problem and all I did was change that last little bit. And you can see right here, oops, wrong button. All I did was add that little piece. We cool? We went over a lot of those last time, but I did a little bit of review to make sure we're ready for chapter 8. Here's another one, I'm not going to go, but in your notes, this one has an individual one and it has a sample one, and I have another one that has an individual one and a sample one. I have another one that has an individual one and a sample one. So you've got plenty to look out there. Now, the good news is chapter 8 is a lot like chapter 5, which is why I put them together. And there's really not enough information in chapter 8 and chapter 5 for me to make a test on it, which is why I put it at the end. Okay? So, there's a lot of letters in chapter 8. Don't get your panties in a wad though, because all of these letters are on your formula sheet. And I'll show you, let me come down. I'll show you that all these letters right here are on your formula sheet, but I want to talk about it. N is the sample size. How many people did I ask? How many people did I survey? That's going to be your N. This cursive U is called the population mean. What was the average of the entire group? The X bar is your sample mean. What was the average of the group you asked? What was the average of your surveyed group? This looks like a cursive O. It's like a little O with a tail on it. This is the population standard deviation, or the standard deviation of the entire group. And an S is the sample standard deviation. That's the standard deviation of the sample you asked. Now, y'all, this goes back to the very first day of class when y'all walked in and you had no idea what you were getting into. And I made you fill out those little index cards. And I said, do you have a cell phone? Yes or no? Do you text? Yes or no? And I said, y'all are my sample. 75% of y'all have a cell phone. So I'm going to assume that 75% of tech has a cell phone. So y'all are my sample. And the average of my sample, so my X bar, is 75%. So there were 25 people in this class, so N is going to be 25 because there's 25 people in my class because y'all are my sample. I said that 75% of this class has a cell phone, so I'm going to assume that 75% of all of Clarks Darlington Tech has a cell phone. So if my X bar is going to be 75, then I'm going to assume that my population mean is going to be 75. If my standard deviation for y'all is 1.2, then we need to find the standard deviation for the population. We're doing the same thing that we did the first day of class, y'all. We're just going full circle. We're just bringing it back together. Now, standard deviation, I'm just reminding you, if it's the standard deviation of the sample or the standard deviation of the population, standard deviation represents the jumps. How far am I jumping? That's your standard deviation, that's your spread. Now, and remember y'all, when we did that chapter on one-bar stats, and I told you that the first thing was the mean, really didn't talk about it, but it was called the X bar. That was the sample mean. Because what did y'all do? Y'all went into L1 and you put a bunch of numbers in there. So this was the average of the numbers that y'all put in there. It was the average of the sample that y'all put in there. That's your X bar. SX, that was your standard deviation, because I said, oh, your standard deviation is your SX, not your sex. SX, right here. That was your sample standard deviation. That was the standard deviation of your sample of data. N is how many numbers are in your list. N is your sample size. How many numbers did you put in there? So you've been seeing these things, but we really didn't call them the name yet. So like I said, this is the chapter that's kind of bringing it all together. Now, and like I said, down here, we have a lot. These are the three right here that I put on the formula sheet. N is going to be your sample size. How many pieces are in your data? How many pieces of data are in your list? This cursive U is your population mean. What is the average of your population? X bar is what is the average of your sample. Okay? Now, we talked about this last time. We said if there's just a couple of people in the picture, if there's a tall person and a short person, it's going to look skewed. Or if the people are the same height, it's going to look uniform. So no matter what it looks like in the beginning, if I put a bunch of people in a picture, it's going to look normal. So as the group gets larger, the more the curve is going to look symmetrical or normal. We talked about that last time. And the skinnier the people are going to look, which means the smaller. So the larger the group, what happens to the standard deviation? What happens to the size of the jumps? They get smaller. People look skinnier. So that's what this page is talking about. Now, do you also remember, this was back when it was so easy and y'all didn't know how easy it was? Remember when, this was like the first week of class, I talked about wiggle room? Remember that? And I gave you a number like the error is the mean is 75% and the margin of error, remember that? The margin of error is 5%. So y'all went 5% this way and 5% this way. Well now, instead of me telling you the margin of error, you're going to have to calculate the margin of error. So you now know a little bit more. So I'm not going to spoon feed it to you. I'm going to give you a formula, and you're going to calculate the margin of error. So the margin of error, standard error, is the standard deviation of everybody divided by the square root of how many people are in the group. So this is the standard deviation of everybody. And this is on your formula sheet. Standard deviation of everybody divided by the square root of n. Now we hadn't talked about what's on the exam yet. Remember, you only have 2 questions on the exam. So don't get your panties in a wad yet. So, let's look at some problems. Come on in, boo. You good. She woke up late. You fine. All right. This problem says, given the population average, the population standard deviation, and how many people are in the sample, find the mean and the standard deviation for the distribution of sample means. So, we have a simple random sample. There's 49 people in the class. It is obtained from a population whose average is 80 and a population standard deviation of 19. So, they want me, and I'm going to show it all to you so we can see it. Do you remember, this is exactly what we did in chapter 5, y'all. We have a normal distribution. If the mean of the population is 80, and this is individual data, if I put 49 people in there, do you agree the mean is still going to be 80? So if I have, if this is individual, and this is grouped, my mean is going to stay the same. So that was the first question. The first question says find the mean. My mean is going to be the same whether it's grouped or individual. Now, my second question says find the standard deviation. My original standard deviation is 14. This person's 14, size 14, if there's only one person in the picture. But if I put a bunch of people in the picture, do you agree they're going to look skinnier? How do we find the new standard deviation? You take the old standard deviation divided by the square root of
Sample.
the people in the group. So, the new standard deviation is the old standard deviation divided by the square root of how many people you stuffed in the picture. So it's going to be 14 divided by the square root of 49. So, if there's only a couple people in the picture, she was a size 14. But if you put 49 people in the picture, she's a size 2. Stick a bunch of people in that picture. So y'all, we didn't have to find a percentage. We didn't have to shade to the left, shade to the right. They wanted to know two things. They want to know if I have a couple people and a lot of people, what is my mean going to be in both of them? 80. If my old deviation is 14, what is my new deviation going to be? That's all they want to know, which is exactly what we did in chapter 5. So if I come down, this one says we have 36 people in the picture. The mean is 64. The standard deviation is 18. So if the mean on the individual is 64, the mean on this one's going to be 64. If the standard deviation on this one is 18, how am I going to get the standard deviation on this one?
18 divided by
18 divided by
square root
of 36. Those are the only two things they want to know. So this is individual and this is grouped. They just want you to compare the two pictures. That's it. They want you to realize that the mean is not going to change, but the size of the person is going to change as to whether they're in a picture by themselves or whether you put them in a picture with a lot of people. Does that make sense? It's the same thing we did in chapter 5, which is why I brought up some of those pictures in some of those problems in chapter 5 to make sure it's the same thing. All right. Now, for this one, it says we asked 40 women, we picked out 40 women off the street, and we tested them for their cholesterol. The average was a 240.9. Would you be more confident if the sample was 500 women? So if I did a survey and I got 40 women, drew their blood and checked their cholesterol, and Joe did a survey and he asked 500 women, drew their blood and checked their cholesterol, who is going to have better results, me or Joe?
Joe.
Why is Joe?
It's 4.
Who? Why is Joe? He is going to have better results. Why? He's got more people. So the more data you have, the more reliable it's going to be. Okay, so when you look at statistics and somebody said, 100% of my people use Crave toothpaste. Well, now you're going to say, well, how many people did you ask? If you only ask 4 people and 100% have it, but if you ask 5,000 people and 100% have it, it means something totally different. So for this problem, if 40 ladies got their cholesterol done versus 500 ladies, this one's going to be more reliable because it's more representative because you have more data. Okay? Bless you, bless you. Bless you. Bless you.
Thank you.
Y'all, I could totally see myself doing this problem. I don't drink caffeine at all, like none at all. I think I would go crazy if I'm already so over the top that if I drank caffeine I would be. But when I go to a grocery store or a gas or send my husband into the gas station to get me a drink, I like to drink Gatorade or water or Sprite because it doesn't have caffeine in it. And if you get the bottle, you can see the top. I know y'all probably don't do this, but I'll always say, get the one with the most in it. Because not all drinks are fit, like some are got like an extra juke in it, like an extra swaller. Y'all never noticed that?
I do.
Judy does, okay, I'm not alone. But when you look, if it's in a can, you can't tell. But if it's in a bottle, you know, they all say 12 ounces. But some may have a little bit more than 12 ounces, and some may have a little bit less than 12 ounces, but the average is 12 ounces. So that's what this problem's about. Assume, we're gonna pretend they're see-through cans. Assume that the cans of Coke are filled so that the actual amounts have an average of 12 ounces. Because y'all, they have filled millions of cans of Coke. And if you add them up and divide by the millions, it's gonna average 12 ounces. But some's a little more, some's a little less. A random sample of 36 cans, so we go to the gas station, we buy 36 cans, like go to Sam's, and we buy a case of 36 cans. We pop the top on the first one and we measure exactly. We pop the top on the second one, we measure exactly. So our 36 cans, we measure exactly how much soda we have. And we have 12.19 ounces is our average for those 36 cans. The distribution of sample means of a size of 36, that's our sample, is normal with a mean of 12 and a standard deviation of 0.02. Now, my first question says, how many standard deviations is my mean from the mean of the population? So standard deviations means jumps. So here's what my picture is going to look like. Let's see how far I can go. We have a normal distribution. Coca-Cola says that the average is 12. My little group of 36, the average is 12.19. The question is asking, how many jumps is it from what they said to what I said? Now, I need to, and they tell me that a jump, a Coca-Cola jump, is 0.02. So I need to figure out, how am I going to jump? How many 0.02 jumps am I going to make to get from their mean to my mean? My data point is this. Their mean is this. Their standard deviation is that. I want to know how many standard deviations, how many jumps is it going to take me from here to here? How do I figure that out? We learned this last time. How do I figure out jumps?
With the rules,
With the who?
the rules,
There's a formula that tells me how to find the number of jumps. What is the name of that formula? It's a letter towards the end of the alphabet.
the standard.
The Z-score.
C-score.
The Z-score is the number of jumps, which is data minus mean over standard deviation. I'm going to show it to you bigger in just a minute. What is my data point?
36.
12.19. That's my data.
Oh, okay.
What is the mean?
12.02.
12.00. What is the standard deviation?
0.02.
Okay, so now let me make this go away and let me show you. All pretty. Pretty, pretty. So, Coca-Cola says their mean is this. I said, well, my mean is this. And they said their standard deviation is this. Well, the question says, how many standard deviations, how many jumps does it take to get from here to here? So, Z-score is the formula for how many jumps. So, data minus mean over standard deviation. So I did my data minus mean and I divided it by standard deviation. So my sample is 9.5 jumps above what they said. And we know it's above because 12.19 is above, and because the Z-score is positive, it's to the right or above. Now, if we were really doing this and we were on the test and we were freaking out, we could say 12 plus 0.02 plus 0.02 plus, y'all with me? You could, that's how some of y'all probably would have done it. And you would say, oh, I'm not there yet. Let me add a couple more 0.02s. I mean, you could have done it that way, 0.02, 0.02, 0.02, 2. Ooh, I'm almost there. I just need half a jump. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps and half a jump. Y'all with me? It's another way to do it. So all they wanted to know for number 1 was how many jumps do I need? From what I said with my little sample,